conversion of planes, this time from coordinate to normal representation. This is always a topic with which the teachers and professors try to scare students. So the way how not to be scared is just learn the procedure by heart, practice it, and maybe you can write a short, like on paper you write how it works, the steps 1, 2, 3, 4, or the trick. I'm going to show you the trick in the following, and then it will never be a problem again. Then when you need it, maybe for exam, when you know it in advance, you can just look it up, right? And that's it. It's not too complicated, I would say. You just have to practice the procedure. When you know the procedure, you just apply it. So you don't have to think a lot, actually, when you convert planes. So, but I'll show you in the following clip how it works. How to convert planes, this time from coordinate representation to normal representation. And I'm going to show you how to calculate this conversion with an example. So we have given a plane which is E 13x1 minus 30x2 plus 61x3 equals 631. And we want to convert to normal representation. So one thing you should know about the coordinate representation, which is this, so this is coordinate representation, is that the coefficients of those x's are the elements of the normal vector. So these three coefficients are the three elements of our normal vector. This is one thing you have to know. The other thing is what exactly is the normal representation. So we are going to have a look at that. So normal representation looks like this. We have x minus something called OP, and I have to add, I need to add that OP is the support vector of our plane. So however you want to call it, this you can also call maybe a small p vector or something, whatever. You know, you just have to know what it is, or maybe also tell your professor or teacher so that he or she knows in the exam what you mean. But basically it looks like this. N is the normal vector, and this is the support vector, and then we just have to find out normal vector. We already know from the coordinate representation, right? And the support vector we don't know yet, but of course we can calculate it very quickly actually. So N, we know. Point P, we don't know, but we know something else. We know the trick how to calculate it. And actually one thing is, maybe we call this here, this number, we call small b. This is a b. And the way to calculate the point now is the following. So we know the coordinate representation is n times x, so vector n times vector x equals vector n times vector p, and this is the support vector of point P. And then we also know that this on the right side is actually n1 times p1 plus n2 times p2 plus n3 times p3. And we also know this right side equals b equals 631. And then there's a trick how to find 3 points very quickly, which is just divide or just set two of the p components 0. So either we set 1 and 2 0, 1 and 3, or 2 and 3. I'm going to show you in a second what I mean with this. So just as I said, there are 3 points. I call it P1. don't mix it up with a component. This is a vector, this is a component of a vector, which is b divided by n1, 0, 0, and you have to make sure that n1 is not 0, because division by 0 is forbidden. P2, vector P2 is 0, b divided by n2, 0, and then we have to make sure n2 is not 0. And P3 is 0, 0, b divided by n3, and here also make sure n3 is not 0. So the trick is, this is the important equation you have to look at. You should also be able to reconstruct it in an exam. So this is what you have to know. And then we can say, okay, we say P3 is 0, P2 is 0. Then those expressions disappear, and this expression stays, n1 times p1. Then it's quite easy. We know n1, then we just divide 631 by n1. We end up with p1, and the other p components are 0. Same thing when we say p1, p3 is 0. Then we divide 631 by n2, and we end up with p2, and the other two components are 0. Same thing here again, just to show you how it works. P1, P2 are 0, P3 we don't know yet. N3 we know, so we divide 631 by N3, we end up with P3. And these tricks that I just explained are here reflected in our 3 points. So in this case, the last two components are 0, so we divide by n1. Here, first and last component are 0, so we divide by n2. Here, first two components are 0, so we divide by n3. And this is it. So it's not very difficult, it's actually very easy. You just have to remember like the trick that you have to apply the general definition of the coordinate representation. And then you have it. Then finally we can write down our normal representation, which is x, okay, that's easy, minus, then we need a point, then we can say, okay, we take maybe something like P3, and we say 0, 0, and then we have to divide 631. We can try whether it's possible to divide, but probably not. And then we just leave the fraction. It can be made easier. So 631 divided by 61. So just as we said, 0, 0, 631 divided by 61. I know this looks a little bit ugly because we have a fraction in the vector, but this is completely valid. This is completely correct to do it like this. And then we just multiply with a normal vector. Normal vector is easy. We just remember normal vector is visible in the coordinate representation. So we say 13 minus 30 plus 61. That's our normal vector, equals 0. And then we're already finished. So it's very, very easy. You just have to remember the trick that you apply the general definition of the coordinate representation. Then you look at the right side. Then you can, if you need to write down the full definition, you can write like this. The three components of the point P. And then do the division. You have to make sure that you don't divide by 0. That's not allowed. And then you just have to put in all the information in the definition of the normal representation. And then you're finished. So not too difficult. This is how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.